Hey, good morning. You made it through the first quarter. You're 1/4 of the way through your freshman year. Well, we got today still. Anyhow, nice job on the test yesterday. I seen some really good scores. We're finally kind of coming together here on solving problems and isolating the variable. We have one last thing to do here before the fall break, and that is to put two things together. If you remember back to last Monday, we did absolute values and we isolated the absolute value sign. We rewrote it twice, once with a negative and once with a positive. Then we worked on inequalities, and now we're going to put the two together. And so we only have 16 problems today, and I'm going to do like about 4 or 5 of them just to kind of get you started. But as soon as you kind of get the gist of things, you're more than welcome to just kind of go out on your own and finish up this paper. My hope is that you probably get it done today so you just don't have it hanging over your head. There is no quarter grades. This year is the first year that ALA went to semester grade. So after the fall break, whatever your grade is, it still just kind of continues with that grade. I see some of you are going to be coming back after the fall break, and so that's great. Just kind of some kids are asking what materials they need. For sure, bring a calculator every day. And then 3-ring binder would be really helpful because we do study guides. You've been doing them at home, but when you're in class, I grade them as a notebook grade. I can't do it when you're online because you'd have to give me 40 pages, and I can't have you upload 40 pages like that. So I do a notebook check on in-class learning. So a 3-ring binder would help to keep all those guys organized. And then for sure, for the next quarter, we're going to need a ruler. We do a lot of graphing of linear lines and solving problems. So make sure you bring a ruler. Okay. All right. So here today, I want to kind of go to the back page because we have more room on the back here. I tried to give you enough room to do it, but we don't have a study guide today, so we're going to do both. We're going to kind of incorporate a study guide into our practice sheet. So on absolute values, we're going to kind of just do some drawing on the back here until you kind of get it. So we'll do about 4 or 5, and then we'll start looking for a pattern here that you don't have to keep drawing all these things. All right, well, if you remember on absolute values, we can kind of think of this. So these are also your notes. So if you'll just draw this for a little bit. This graph here says everything on this side has to be greater than a 30. So if I made a number line here, and this is not the answer, if I said 30 and 30, I like working on the positive side. If I was to graph this absolute value, forget the 5 for right now, but if whatever's inside of this absolute value sign would have to be all numbers greater than 30. So really, like 31 would make a good case. That's greater than 30. But I could also say absolute value of negative 31. And so what's going to happen is my graph is going to look like this. Okay, but that is not my graph. That's my graph if there was a 5, and I want to know the numbers 5 times what would make this all true statements. And so this is already in my head. I'm thinking, okay, this is going to be an or statement because that's the way my graph goes. Okay. Now, when we do the absolute value, here's kind of the tricky part. Let's go to the solving part here. Remember when absolute values, we said, hey, whatever's in the absolute value sign, we said it twice to get rid of the absolute values. We say once with a negative 30. I want to leave my sign absent there for a second. And then we say we do it once with a positive 30. Now, when we go to the negative sign, though, what we want to do is whatever this sign is to help us solve this problem, we want to flip the sign. Remember how we flipped it when we multiplied or divided by a negative? Well, we changed it from a positive 30 to a negative. Now over here, I want to keep my sign the same. Okay. Now we just continue solving this here. Dividing both sides by 5. So now I got x is less than negative 6. Negative divided by positive is a negative. And then over here I got divide by 5, divide by 5. I got x is greater than 6. Now it just worked out that this is a negative and a positive 6, but those numbers, as you know, are not always the same. Now, standard form here. I know it's an or statement because of my graph up here before I solved it. I'm looking for all numbers that I could put in for x that would make this statement true. That if after I multiply it by 5, it would still make this statement true. So I want to put the or statement in here, and then let's think about our answers here. X is less than all numbers less than -6. So like -7 would be a number that would work in there because that's less than -6. So if I plug that in, -7 times 5 is -35. The absolute value of -35 is 35, and 35 is greater than 30. So I checked one of the numbers, and it appears that it works. Now, what they want is the graphing of the solutions, not the graphing of the absolute value. We want the solution. What are all the values that x can be in order for that to be a true statement once I plug these numbers in, multiplied by 5? So we go down to our graph. I'm looking for an or graph, and I'm looking for x is less than -6 and more than 6. So let's see. I'm looking at that first one there, letter J. Do I see any other ones? There's a -2 and 6. These are all my or statements over here, so I think I like the letter J. Now, I would recommend that up here by the problem number, you put the letter J. Okay, this is really what I'm looking for. This is the solved part. That's the solved part recorded correctly. So I'm hoping you're recording them correctly on your paper. But when you go to put your answers into the Google Forms today, to make it easy on us and not have to do all those inequality signs and spaces and the or word and the and word, all I did is I said on problem 9, what letter matches with it? And you'll just write J. All right. Let's go do another one here. Let's do one and see if we can kind of see a difference here. If I, again, was looking at this graph, and so we're not going to do this all the time. We'll do it like maybe 4 times. Whatever's in the absolute value on this one, these are our notes, so just for a little bit, bear with me. I'm looking for all numbers less than 4. So again, I like the positive side. So like 3 would be less than 4. Whatever this in the absolute value was added up to a 3. So really, I'm talking about numbers that go this way. If I said, down here I want a negative. If I said a -3, if I put a -3 in there, the absolute value of a -3 is 3, and 3 is still less than 4. So on this negative side, my graph would head this way. Okay? Now again, you're probably scratching your head or saying, I don't get it. Just be patient. It usually takes about 3 or 4 problems before we finally start to discover some patterns here. All right? So this is what I'm thinking in my head. Now let's go down and solve this one. So we said we're going to take this 3 plus y. We're going to change that to a -4 when I write it, but I want to change my sign to go the other direction when I write my -4. Now I'm going to say 3 plus y, and I'm going to keep the sign the same on this side, okay? Because it is a +4. Remember, absolute values can never equal negative, and I don't think you have any on today's paper. So that's a good news. Okay, if it was a negative on the right-hand side of the inequality sign, well, that would just be an automatic no solution. All right, let's continue solving this one. So I want to subtract 3. Now I get y is all numbers greater than -7. And y is less than 1. So you see, we don't have matching numbers like we did up there. So that was a big problem on absolute values that first Monday 2 weeks ago. Everybody just solved for the first one, and if it was a 7, then they just put -7. That's not true. All right. Now we know this is an and statement, and when we did inequalities, we learned how to write them in an and statement with the x in the middle. Well, in this case, it's going to be a y. Let's use the correct variable. Now, the bottom number is -7. The highest number is a 1. And if you remember, on inequalities and statements, they point to the left. But look at this. See how the fat side's towards the y on the negative low number? Still that way. Y is less than 1. So this is it written in standard form. When I come down to my graph, I'm looking for an and statement, so I want to look over here on this right-hand side. And I'm looking for, and I have to kind of read it backwards, where y is all numbers greater than, so I'm looking this way. Y is greater than -7. And I'm looking at P here. That would be a -7. Greater than 7 would be this way. And yet y is less than 1. Yep, that's less than 1. I have open circles. Over here on my problem, I had no or equal to signs, so I think I like that one. What did we say? Letter P. So again, I would put these letters here, so when you go to Google Forms, all you have to do is say 12 is P, 9 is J. Let's go over and do another one. Let's look for a pattern here. Notice that on 9, it was a greater than symbol. 10 or 12 was a less than symbol. Here's another greater than symbol. So what do you think is going to happen on this one? Is this going to be an and or an or statement? Let's think about it one more time. Here's my thinking before I solve it. This amount right here is going to, so if I had a number line, here's -20, here's 20. I want all numbers, and again, I like this side, greater than 20, so that would be like 21, 22, 23, numbers greater than 20. On this side, if I had a -21, well, the absolute value of a -21 is 21, and so my graph would go this way. So we start to see this pattern here that anytime my inequality is a greater than, this is going to be an or statement. Okay, that helps me on my graphs down below. Now, here we go. Let's solve it. I'm going to do 5x minus 10. And I'm getting rid of the absolute value sign, so we were told, write the problem twice. Once with a negative. I want to flip that sign because I'm on -20. And then I'm going to have 5x minus 10 equals, well, not equals, greater than 20. Again, keep the sign the same right here on the positive side. So here we go. Let's add 10 to both sides. I got 5x is less than -10. Divide by 5. I'm getting x is all numbers less than -2. Over here, let's solve this side. Looks like greater than 30. Divide by 5. I'm getting x is greater than 6. Again, we have two different numbers. We know it's an or statement. Because the negative side, we kept it on the left side, all we need to do is just write the word or in here. So I'm going to look for graphs that x is all numbers less than -2. R is that way. And greater than 6. Nope, that one didn't work. How about our, yep, they're all no or equal to signs. Here I have one down here, B. That is less than -2, but it's also greater than 6. So I think I like the answer B. Now at this point, you're probably A-okay. I'm going to do one more thinking, and then hopefully after 4, you don't have to draw all this thinking sign. But I want to do one with the 9 out in front here. Before we solve absolute values and rewrite it twice, the rule was we have to get the absolute value sign by itself. So I got it right now. It says 9 times everything. So I'm going to divide both sides by a 9. Still have my absolute value sign. And I still have my inequality sign, but 36 divided by 9 is 4. Now I have my absolute value sign. So again, if I'm going to look at my graph for this one here, I have a -4 down here and 4. This is my thinking part. I want all numbers less than 4, so that would be numbers heading this way. And this is the harder part. Absolute value. If I had a -3 in here, absolute value of a -3 is a +3, so this line would be going this way. So again, when it's a less than symbol, you'll see over here on number 12, we had a less than, we had an and statement. So I know this is going to be an and statement. The lines are going to go towards each other. Okay, let's go down and solve it. We want to say m plus 1, I'm going to flip that sign, is a negative 4. M plus 1, keep the sign the same way it was, positive 4. Okay. Okay, let's go ahead and solve it. Minus 1, minus 1. I'm looking for numbers greater than or equal to negative 5. And I'm looking for numbers less than or equal to 3. Now I know it's an and statement, so I'm going to put my x in the middle. Negative 5 is my smallest number. 3 is my largest number. Down here, this one says m is greater than, oops, I got to change my variable here. So used to x's. Fat side's towards the m on my negative 5, so fat side still stays towards the m. Over here, it's pointing towards the m. So again, if you start to recognize and statements will always point towards the left. I'm looking for an and statement where negative m is greater than negative 5 or equal to, so I'm going to look for a solid dot. So it can't be h, can't be l. That dot right there is looking pretty good because that starts at negative 5 and m is all numbers greater than negative 5. And I want them less than 3. And so I got negative 5, negative, oh wait, nope, that's a 5 there. I'm looking for a 3. So it can't be that one. I almost fell for it. 3 is right here. So now I'm down here on T, looking at T. T's looking pretty good though. I think I like the letter T. So somewhere nearby, put 14 as the letter T. All right. I guess we could go to the other side and let's go ahead and fill in some of these letters here. Number 9, wherever I see a 9, I'm going to put a J up there on my puzzle. So let's see if we find a 9. There's a J right there. Directions say graph the solution of any equality on the number line, then find your answer in the column. Each time the exercise appears in the code, write that letter. So every time I see a 9 up there, I'm going to write the letter J. I think I only see it once, though. What was our other answer here? We had 12 was a P. So everywhere I see a 12 up there, I want to put a P. I see a 12 right there. I don't think I see any more 12, but you see how I see a lot of 14s in there? Okay. And 13 is a B. I see a 13 right there. I see a 13 there. I think that's all I see. All right, so you're kind of getting the hang of it. We just did 4. I want to do one more, but if you kind of got it, you can just continue on and wrapping this paper up. I would highly recommend that, even though it's fall break, you get this one out of the way today, put your answers in and turn it in, even though it's not really due until Tuesday, 2 Tuesdays from now. You just have it hanging over your head the whole time, or you'll even forget after about 4 days that we even had an assignment. So let's start this next quarter off on a good note with this paper already done. All right, so I'm going to turn you loose if you're okay. If you're still needing to kind of see another example, let's just do one more. But have a good fall break, and we'll see you in about 10 days. All right, if you're still sticking around, let's maybe just do number 16 yet, because we have a number that's outside the absolute value sign still. So I want to divide both sides by a 3, because that says 3 times everything there. So let's divide everything by 3. All right, so on this side, the 3's cancel out. Again, I still have my absolute value. I cannot make that absolute value sign go away until I actually rewrite it twice. That's how you make an absolute value sign go away. If I do 48 divided by 3, I'm getting 16. Now, I don't know if you still need this thinking part. Is this going to be an and statement or an or statement? Right. It's pointing to the left, and we notice that anytime it's pointing to the left, we have an and statement. So let's see if it works. So really, I'm looking for, before I even saw, nope, I need it right here. 16 and 16. Negative 16 and 16. So I want all numbers less than 16. So that'd be like 8, 7, all numbers going this way. And then if I had negative numbers, well, I could have a negative 8. Absolute value of a negative 8 would be a positive 8, and 8 is less than 16. So it's going to be an and statement. My graph's going to be going in this way. Once again, this is not the answer. That's my overall goal, that once I do all the math inside my absolute value, then that would be there. But I'm just looking for what's all the numbers I could put in for the letter T to solve this problem. So now we're going to go and we're going to rewrite it twice. I'm going to say 8 plus 4t, flip the sign, negative 16. 8 plus 4t, keep the sign the same, 16. Let's go ahead and solve now for t. I need to subtract my 8's first. PEMDAS backwards. I have 4t, negative 16, and negative 8. It's negative 24. And then one last step. Let's divide both sides by 4. T is greater than negative, divide by 4, 6. Go over here and solve the other one. Again, I want to subtract my 8's first. 4t less than, that's going to be 8. Divide by 4, divide by 4. I got t is less than 2. It's an and statement. I always want to write my answer in standard form. So I'm going to put my t, man, I always want to write an x. T, down here's my bottom number. So I'm going to put minus 6. That's my 2 is bigger than 6. So I'm going to put my 2 over here. I'm going to put my signs pointing to the left, less than symbols. There is my final answer written in standard form. Now let's go back to the graph. Sometimes it's easier to look at this one here for your graphing, because this really does say t is greater than 6. And I don't want the or equal to sign there. And that was a t. Now I'm really messing this up. What do we have? T and then less than 2. So I'm looking for all numbers. It's an and statement, so I'm going to be over here on the left or the right side of my tables here. I'm looking for a negative 6 and less than 2. I think this is that one. Let's see. Oh, no. It's an open circle, so be careful. Open circle, open circle. I'm thinking I like the letter H. The lights just went off, so I can't even see my regular paper here. I'll be right back. So I think I like H. So let's come up here and let's just put in H. So when we put our Google Forms, everything's good. All right. I want to turn everybody loose. But look at all this math work. And this is why Fisher was so adamant about the first month of school, that even if they're mental problems, I didn't care. Show your work, show your work, show your work. Show it systematically. Show it step by step, because all of our work is going to make this like V-shaped coming down to our answer. Okay, that is a ton of work, ton of pencil lead. All right, so now I want to turn everybody loose. Have a good fall break. I don't know why I keep saying spring break, but have a good fall break, and we'll see you in roughly 10 days.